This is a solution for a series of questions covering the sublearning outcomes of Newton's laws of motions and identifying forces and loads. The basis of these questions rely on a diagram depicting an iceberg being pulled by a tugboat. We are given that the iceberg has a volume of 100,000 meters cubed. The first question asks us, what is the mass of the iceberg, given that ice density is 917 kilograms per meters cubed? Recalling that the formula for density is mass over volume, this is symbolically represented as rho equals m over v. Rearranging for m, we have v times rho, and we are given that the volume is 100,000 meters cubed, otherwise shown as 10 to the power 5, and we have rho to be 917 kilograms per meters cubed. We can also cancel out the units of meters cubed, giving us a unit of kilograms in the final answer. And now simplifying, we get 10 to the power of 8 kilograms. Our final answer for the first question is now m equals to 1 times 10 to the power of 8 kilograms, and this is the mass of the iceberg. The second question asks, according to Newton's first law of motion, when the iceberg is at rest, it will remain at rest until an external force acts on it. This question can be answered in a true or false statement. And we can recall that Newton's first law of motion is that an object at rest will stay at rest until an external force acts upon it. Therefore, recalling from the question that the iceberg is at rest, it will remain at rest until an external force acts on it. Therefore, the statement is true, as it obeys Newton's first law of motion. Question 3 says, according to Newton's first law of motion, if the iceberg is being swept along at a steady speed by an ocean current, it will slow down even if no external force is acting on it. Newton's first law of motion also states that an object in motion will stay in motion at a constant velocity unless acted upon by an external force. Therefore, if the iceberg is moving at a steady speed, it will not slow down unless an external force acts on it. Therefore, this statement is false. Question 4 is, according to Newton's first law of motion, if the moving iceberg suddenly encounters an island or human-made offshore structure, it will continue moving. Referring back to Newton's first law of motion, if the moving iceberg encounters an island or a human-made offshore structure, which are in this case external forces, it will not continue moving in the same manner as its motion will be affected by this interaction. As a result, the statement is false, since an object stays at constant velocity unless acted upon by an external force. Question 5 indicates that the tugboat is applying a towing force of 30 kilonewtons to the iceberg using a cable, and the drag forces from the movement of the iceberg in the water are ignored. We are asked to find the acceleration of this iceberg. Now, we can recall from question 1 that the mass of the iceberg was 1 times 10 to the power of 8 kilograms. Now, using Newton's second law of motion, we have force equals to mass times acceleration, otherwise shown as F equals ma. Rearranging for a as we're solving for this, we have F over m, which can be simplified to 30 times 10 to the power of 3 newtons divided by 10 to the power of 8 kilograms. We recall that 1 newton is equals to 1 kilogram meters per second squared. And now simplifying this, we can cancel out the unit of kilograms as well as some of the powers of 10. Evaluating this fraction, we get an answer of 3 times 10 to the minus 4 meters per second squared. This is the final answer of this question, and we now have a equals to 3 times 10 to the minus 4 meters per second squared, and this is equivalent to the acceleration of the iceberg. Now we know in this case that the initial velocity is 0, so we can simplify this equation to v equals a times t. We have to rearrange for t as we are solving for this in this question. We now have v over a, which is equivalent to 5 kilometers per hour over 3 times 10 to the minus 4 meters per second squared. We notice that there is a mismatch of units, as our denominator is in meters per second squared, while our numerator is in kilometers per hour. In this case, it would be easier to convert our numerator to meters per second. We can first convert the kilometers to meters, by recalling that there are 1,000 meters in 1 kilometer. Therefore, we can multiply by 1,000 meters over 1 kilometer. And similarly, we know that in an hour there are 60 minutes. And therefore, we have 1 hour in our numerator and 60 minutes in our denominator. And now converting the minutes to seconds, we recall that there's 1 minute and 60 seconds. And this ensures there are no unit mismatches within our equation. And now we can go along with the calculation. Using a calculator to evaluate this, we get an answer of 4,633.33 seconds. And now, since the question is asking us for a solution in hours, we can convert back to hours by remembering that in 1 hour there are 3,600 seconds, and simplifying this, we get a solution of 1.286 hours. And this is the final answer. And this is equivalent to the time it would take for the tugboat to pull on the iceberg for it to reach a speed of 5 kilometers per hour.